Hi, this is Grace, and this is my reassessment for Standard 1.4 and 3.1 on using Problem 30 from Chapter 3. And here's the question. So I first listed out all the constants that I would need, which is big G, and all the information given to me from the problem. For part A, which is to find the approximate momentum in the future. I mean, a very near future, but yeah. And this is the delta t value, and I listed out the equation for calculating change in momentum, just so I have a reference. I first calculated the initial momentum, and I didn't use the Lorentz factor because their speed is nowhere near the speed of light, so it's not really necessary. And the distance between the two is, I just subtracted the position for the second star from the first one, and I calculated the F net using the gravitational force equation, which is big G times mass 1 times mass 2 divided by the square of the magnitude of the distance. And I wanted to make it a vector, so I put in a unit vector there. So now I have all the factors I need to calculate the future momentum. So I just plugged it all in and got this number right here. For part B, I said that my result for A is an approximation because F net isn't exactly constant during the time interval, even though it is very small, but it's not like 100% precise. For part C, we are calculating the future position. And here's the formula and the formula for V average. I first calculated the future velocity of the star using the future momentum divided by the mass, and I calculated the average using V future plus V initial divided by 2, and I plugged everything back into this equation right here, and I got this answer right here. And for part D, sorry, it wasn't showing up. I said that my result for part C, I guess, it doesn't make much sense for it to be part B, so I just changed it to change this B into C because I thought it made more sense. It's basically the same thing for part B because the star is obviously still moving throughout the interval, so we can't be exact about the V average, which makes this result a very close approximation. Thank you.